Today we're going to be talking about origins of the universe and light years. You guys did a great job with your research and your scale models of light years. But I just want to clarify a few things. Scientists have been studying the universe for thousands of years. The universe is this huge place and we barely know anything about it. Some of the models go from like pretty simple, like the Earth was flat, to pretty complex, like the Big Bang Theory. Remember that these are just theories and that you just need to be educated about them, but you do not have to believe in any of these theories. So the first ones we're going to talk about are Ptolemy and Copernicus. I can get my thing to work here. I'll put it on full screen for you. Alright. Ptolemy was the first guy back in like 100 AD. He came up with this idea called the geocentric model. He basically put the Earth as the center of the universe and said that the planets, the known ones that we knew at the time, I think the last planet we knew of at the time was Saturn. So the first 5 or 6 planets plus the stars and the sun all revolved around the Earth. He was pretty good for his knowledge at the time. He had no telescopes, no technology, pretty much just sat outside and observed. So I think he did pretty good. That lasted for about 1,300 years until Nicholas Copernicus came along in about 1470. He changed up the model and basically said that the sun was the center now of the universe and that the planets, including the Earth, and all revolved around the sun. However, he was a little off when he said that the sun was basically stationary and the stars were too. None of that moved according to him. But this really cool guy named Johannes Kepler started studying Copernicus's model, and he came up with these 3 planetary models, or these 3 planetary laws, in about 1600. He came up with these first 2 and said, he started looking at his model and said, it's kind of weird. They don't really go in a circle like Copernicus said. Mars never would match up in his with his telescope. He did all his math, couldn't get Mars to match up. So he basically figured out in about 1609 that all the planets orbit in an ellipse, which is like a elongated circle, more like an oval. And he also discovered that as planets come closer to the sun, they tend to speed up, and then as they move away, they slow down. And about 10 years later, he came up with this last law, and he said basically, depending on how close you are to the sun, some of the planets are going to orbit faster than others. So, for example, Mercury orbits very quickly within about 70 days, while Pluto, on the other hand, way out there, takes years to orbit, longer than Earth. Okay? Makes pretty much sense. So the most well-known theory of the origin of the universe that includes everything from galaxies and stars and planets and our solar system and our Earth is the Big Bang Theory. And basically was brought up by George Latimer in about 1927. He came up with this theory. He says that basically 13 to 15 billion years ago, the universe was in this tiny little molecule. And there was some type of explosion in that molecule, and suddenly the universe began to expand. And it is continuing to expand in all directions. So it goes from very small, it's kind of like a balloon blows up. It kind of expanded and it's still going. He had a lot of evidence thanks to Edwin Hubble and his telescope. They found some radiation out there and some hydrogen, things that looked millions of years old to them. And plus Hubble's telescope has been taking pictures, and those pictures look like things are moving away from us. So that all helps with this Big Bang Theory. There are other theories, though, more simpler theories that are trying to basically now figure out how the sun and the Earth and the moon got here. A lot of them were very curious about how our moon got where it is. So these first 2 are kind of similar. This is the nebular hypothesis and the accretion theory. Basically, the nebular hypothesis is this giant gas dust cloud, and it has collapsed and it's flattened out into kind of like a pancake. And inside this pancake are these little bitty pockets of dust, and this dust is basically condensed and made different planets, and that's how we got our sun and planets. The accretion theory, same thing, another dust cloud, except for this time, instead of having pockets of dust, they have these chunks of material that later became planets. The capture and gas cloud theory. The capture theory is about 1964. It basically says that the planets and moons were wandering around in space somewhere, and suddenly the sun's gravity just went out there and captured them, and they've been orbiting us ever since. Gas cloud theory, same thing. Sun, however, this time captured little pockets of gas, and those, the sun's gravity and all that stuff basically condensed those pockets of gas into the planets and moons. The last ones we're going to talk about are the fission, planetary collision, and the stellar collision theories. The fission theory is kind of my favorite. Basically, the sun just burst one day and spit out all these little planets and moons. It's kind of funny. I kind of like that one. The planetary collision model says that basically two planets collided with Earth. There was a smaller one. They named it Theia. So basically Earth and this planet Theia, which is about the size of Mars, collided one day, and a chunk of the Earth became the moon. That one actually has some pretty good backing to it. Back in 1764, this guy named Charles Messier found these stars, and they called them the Messier 30. And in that, there is some of the stars that are much, much younger than the stars that are in the little grouping. And so they believe that that could have been right after those two collided. Then some of that newer stuff is from what was left over. The stellar collision, same thing, except for this time instead of planets, you have two stars that are colliding, and the impact, when they impacted each other, all the remaining dust and gas and stuff became planets and moons. We're just going to clear up. Those are all the theories that are known right now. I believe that the universe is going to be ever-changing, and that as technology changes, we will see millions of more theories of how the universe got here. I think it'll always be changing. In the last 5 years I've been teaching this class, we have looked at millions of, not millions, but at least like 20 different theories of the universe. And I believe that by the time you guys graduate college, there'll be about 20 more that I'll be teaching. So, again, it's ever-changing, and it's nothing that you have to believe in. It's just something that you need to know about, that the universe is out there, and that we still can't figure out how we got here. Light years, just to remember again, it's basically how far light can travel through a vacuum in 1 year, and that vacuum would be like space. Space is a vacuum. It is a distance. I know it has that year in there, and sometimes people get confused and think that might be a measurement of time, but it is of distance. And 1 light year is about 10 trillion kilometers. So that first star, that Proxima Centauri, which is about 4.2 to 4.3 light years away from us, if you were to multiply 4.3 by 10 trillion, you would get 43 trillion kilometers. That's how far that star is away from us. Just want to clarify that for you.